التصوير ما يعطيك شيء واضح، مو اللي واضح. زاويتي أنا كلش. خليك عادي محمد، عادي خلصت. سريع، حيل سريع.
السؤال حاجة مش فاهم.
ركب الخرام صدق هو؟
ما تعرفش يعني يسوي صديقنا هناك أدخل حافظ. Sorry, yeah. I've done a mistake, so I need to do it again. Because there's supposed to be one more button coming out from here, but it doesn't have any. So that's what I'm worried of right now. It's okay. Just continue with it. Okay. Right now you have that. You already have that. Okay. If you run it, runnable server, no runnable server available. That's supposed to mean. Oh, okay. For this part, you need to, if you want to set the continua, so go on physic, continua, and then look on the physic. When you go on there, no wonder it's not working just now. Okay, what you want is, based on the tutorial, it says that you need to study gas, coupled flow, ideal gas, and turbulent and spallat. So all this, for all this, you need to do a research, saying why do we need to do on spallat, why do we need to do turbulent. It doesn't matter what you want to put in, but at the end of the day, what you want is a two-dimensional, because the coursework says you to do the two-dimensional. And then steady is up to you. Why do you want to put steady? Gas, of course, because this is an airform, so it's a gas. So coupled flow, why do you need to do coupled flow? Why do you need to do ideal gas? Why do you need coupled energy is come with the coupled flow, so you don't have to do that. But what I'm trying to say is, the most you need to do the research on this. The analysis is must be on this side. Two-dimensional is because why do you choose steady? Why gas? Why do you choose coupled flow? Why do you use ideal gas instead of constant density or real gas or something like that? Why the turbulent? And then why do you want to use Spallat Almaraz? You have to do research on that. Close that. Now if you go to, let me just check. Yep. Okay. The thing that I'm looking for just now was this thing. This thing. Because if you don't have this button, meaning that you can't add the velocity. So now I have the velocity. What do I want to do with the velocity? Remember the coursework says that it must be 50. So where you can put that is go to region, subtract. This is supposed to be fluid just now. Go to region, subtract, and then go to boundary inlet, and then goes to physics values, and then you go to velocity magnitude. Open that, you have a constant, so you can change that. So 50 meters per second. Okay, that's okay. Yeah. So now you have everything already. You have the 50, you have the machine and then all. You have everything. What I haven't choose to if you basically that's the basic thing that have to be in this thing. The most basic thing that have to be in the thing. So you don't okay. When you run it, the residual will be like this. It will go to 3000 because you can okay 1000. Why is it 1000? You can actually change it here in the maximum start.
Mhm.
In the stopping criteria, maximum. You can put whatever you want. You can put, it doesn't matter. But for now, this is the graph that you have.
Mhm.
What you can do with this graph is that you have to do a research on what is this oscillation here, what is this oscillation here. If it gives you like this, what does it mean? Things like that. So I can tell you when you do the calculation and all, you want it to be somewhere there. When you do the graph later for lift and drag, you want it to be like that. Then only you can stop. So meaning if it becoming like this, meaning that you can stop. You can stop and then take the value already because it's already what you call this converge. This is the converge mode. There's a few type of converge, which is oscillation converge, and then there's iterative converge. Sometimes this value here, this graph here, will turns out to be like that. It's a very rough one, but sometimes it will come out like that. So that's for the graph, for this graph. This is for the residual. Because you need to do analysis on this as well, according to the Gauss. So okay, you must be said, oh, why am I concentrating on this? You actually can go to mesh. So right now your mesh is like that. This is the mesh is at 1 meter, I think.
Mm-hmm.
So how do you want to change that? How do you want to change the mesh?
Some accident spot here.
Yeah. I'll teach you that one later. But right now, this is the most basic thing. How you can change the mesh in the box is by changing the base size. What do you want? Like this is the base size is basically the size of all of this. This is 1 meter. So if you change that to 0.5, let's say, and then you press this execute, it will be smaller. And then if you change it again, 0.1, say, you execute it, it will be smaller, smaller and smaller and smaller, smaller. Okay, but from now you want it at 1. Okay, you have the spec. You tell me that, oh, I don't want to count this, I don't want to count that. You just want to count somewhere there and then at the back. How do you do that? It's by creating another parts, creating a block which is on that, just focusing on that region there. It depends on you which region you want to focus on. Okay, so that's for now, that's the region you want to focus on. So you say you want to focus on that, so okay, create it. Non-zero volume. Okay, so the z-axis just now was 0.1, so you want to put that as a 0.1 because the one that we did the first place just now was 0.1, remember? I'll put it 0.1.
Thickness of the F1.
Yeah. The extrude.
Extrude.
It was 0.1, so that's what it's saying. So you give it, you just click once and then you could straight away go up. So it's there right now. So as a block, what I want to make it easy for you guys, change that name again. Rename every time you rename a part. When every time you design a part, you must rename it. Tell them what is that part. What is that? So for this one, I would name it as an area or surface. Actually, because it's small and closer to the thing, I would rename it as surface.
Surface, okay.
Surface. Okay. So you name that as a surface. So what else do you want? When you're looking at this thing, it must have something at the back, because the inlet is coming in, and then there's a must be a wig coming out from the back. So you want that. So you want to look at that. You can't look at this big. So you create another box. Yeah. Create another box by do that. Same thing. But this time start from the tail. Start from the tail, and then look at what size you want to look at that. Okay. Make sure you have them one. It's better to use the number. I usually use the number, it's easier. Okay, so you know that the same. And then the thickness is 0.1, isn't it?
0.1.
Yeah. And for this one,
صوت خبير وين؟
I would start at 1 because 1 is the tail. Because 0 to 1, right? Because yeah, I start at 1. So I have a digit, so I don't have to remember all the long number. It's just matter of thing, and then you just create that. So now you have this back part. Close it, and then you can name that as a trailing edge. Okay, so that's your trailing edge. Whatever comes out, it has details there. You can count it using this thing, but it won't, how would you say, it won't give you an accurate amount that you want there. So that's why you make this box.
Give us accurate.
Accurate value result. You can count it with this, but it's really not. It doesn't show us a very good answer for that. And then, okay, when you're generating this, okay, you have the box and you have the big box.